Hello, welcome to the new section of the course, Angular 2 Testing. The goal of this section is to walk you through the available testing utilities that the Angular 2 framework comes with out of the box, as well as some strategies for deploying these utilities. In this section, we will start with creating a minimum viable unit test suite with Karma, Jasmine, and TypeScript. Then we will write a minimum viable unit test and end-to-end test suite for a simple component. We will then perform unit testing of a synchronous service and component using stubs and spies. So let's get started with the first video of the section, creating a minimum viable unit test suite with Karma, Jasmine, and TypeScript. In this video, we will demonstrate how to put together a very simple unit test suite. It will use Karma and Jasmine as the test infrastructure, TypeScript and Webpack for compilation and module support, and Phantom.js as the test browser. Before you jump into the intricacies of testing in Angular 2 applications, it's important to first examine the supporting infrastructure that will make running these tests possible. The bulk of official Angular resources offer tests on top of Karma and Jasmine, and there's no reason to rock the boat on this one, as these are both fine testing tools. That said, it's a whole new world with TypeScript involved, and using them in tests will require some considerations. First, we will start with a little information on the tools used in this recipe. Karma is a unit test runner. You run tests through Karma on the command line. It has the ability to start up a test server that understands how to find test files and serve them to the test browser. Jasmine is a test framework. When you use keywords such as it and describe, remember that they are part of Jasmine unit tests. It integrates with Karma and understands how to expose and run the tests you've written. Phantom.js is a headless WebKit browser. Headless means it runs as a process that does not have a visible user interface, but still constructs a DOM and has a JS runtime. Unit tests require a browser to run, as the JavaScript unit tests are designed to execute inside a browser runtime. Karma supports a large number of browser plugins to run the tests on, including standard browsers such as Chrome and Firefox. If you were to incorporate these browser plugins, Karma would start up an instance of the browser and run the tests inside it. For the purpose of creating a minimum viable unit test suite, you are fine doing the testing inside a headless browser, which will cleanly report its results to the command line. If you want to run your tests inside an actual browser, Karma will expose the server at a specified port, which you can access directly, for example, visiting localhost 9876 in the desired test browser. The code, links, and a live example related to this video are available at this link. We will start with a package.json file. This still needs to be a valid JSON file, as npm needs to be able to parse it and add to it. Start off by creating the file that will be tested. You intend to use TypeScript, so go ahead and use its syntax here. This is the article.ts file, which I have saved in src folder. Next, we will write a unit test. With the article class defined, you can now import it into a new test file, article.spec.ts, and use it. Here is that file. Jasmine test files by convention are suffixed with .spec.ts. Test files generated by the Angular CLI will exist alongside the file they test, but by no means is this mandatory. You can define your convention inside your Karma configuration later on. Start off by importing the article class and create an empty Jasmine test suite using describe. You can see that I've done that already. Now we will see what describe means. Describe defines a spec suite, which includes a string title called article unit tests and an anonymous function which contains the suite. A spec suite can be nested inside another spec suite. Inside a describe suite function, you can define before each and after each, which are functions that execute before and after each. Inside the spec suite function, write the unit test that is using it. Note that both the code and the test are written in TypeScript. Our next topic is configuring Karma and Jasmine. First, install Karma, the Karma CLI, Jasmine, and the Karma Jasmine plugin. For that, we need to run this command in the command prompt. This is the screen we get. We run another command, install Karma CLI. Karma reads its configuration out of karma.conf.js file, so create that now. This is the file. Karma needs to know how to find the test files, and also how to use Jasmine. For that, we need to modify this file. We will add frameworks and files. In files, we will give the path of the spec.js file. We will also add plugins. The next step is configuring Phantom.js. Phantom.js allows you to direct tests entirely from the command line, but Karma needs to understand how to use Phantom.js. Install the Phantom.js plugin. For that, we go to cmd and run this command. Press Enter and wait for a while. Next, incorporate this plugin into Karma config. We go to the karma.conf.js file and add browsers. We will also need karma-phantom.js launcher. Save this file. Karma now knows it has to run the tests in Phantom.js. Next, we will compile files and test with TypeScript. If you're paying attention closely, you'll note that the Karma config is referencing test files that do not exist. Since you're using TypeScript, you must create these files, install TypeScript, and the Jasmine type definitions. In cmd, run npm install, and you will get this result. After that, add script definitions to your package.json. The script is added. Now we will create a tsconfig.json file. Since you're fine with the compiled files residing in the same directory, a simple one will do. Here is the file. You would probably not do it this way for a production application, but for a minimum viable setup, this will do in a pinch. A production application would most likely put compiled files into an entirely different directory, frequently named dist. Now, incorporating Webpack into Karma. Of course, you'll need a way of resolving module definitions for code and tests. Karma isn't capable of doing this on its own, so you'll need something to do this. Webpack is perfectly suitable for such a task. And Karma has a terrific plugin that allows you to pre-process your test files before they reach the browser. We will install Webpack and its Karma plugin. Run the required command in cmd. We have installed the Webpack and Karma login. Modify the Karma config to specify the Webpack as the preprocessor. This allows your module definitions to be resolved properly. We will add the Karma Webpack plugin in the config. Preprocessors will also be added. Save this file. Writing the test script. You can kick off the Karma server with the karma start karma.conf.js command. Before that, go into your folder. This will initialize the test server and run the tests, watching for changes and rerunning the tests. However, this sidesteps the fact that the TypeScript files require compilation in the files that Karma is watching. The TypeScript compiler also has a file watcher that will recompile on the fly. You would like both of these to recompile whenever you save changes to a source code file, so it makes sense to run them simultaneously. The concurrently package is suitable for this task. We will install concurrently. We will change directory and then run the command for concurrently. Concurrently not only allows you to run multiple commands at once, but also to kill them all at once. Without it, a kill signal from the command line would only target whichever process was run most recently, ignoring the process that is running in the background. Finally, build your test script to run Karma and the TypeScript compiler simultaneously. We will move to the file now. In package.json file, we will add required changes. Save this file. With this, you should be able to run your tests. So, we will navigate to the cmd for viewing the output. Run the command. If everything is done correctly, the Karma server should boot up and run the tests, outputting this screen. It directly opens another cmd. Karma and Jasmine work together to deliver test files to the test browser. TypeScript and Webpack are tasked with converting your TypeScript files into a JavaScript format that will be usable by the test browser. An interesting consideration of this setup is how exactly TypeScript is handled. Both the code and test files are written in TypeScript, which allows you to use the ES6 module notation, as opposed to some mix and match strategy. However, this leaves you with some choices to make on how the test setup should work. The tests need to be able to use different pieces of your application in a piecemeal fashion, as opposed to the standard application setup where all the modules get pulled together at once. This video had TypeScript independently compile the .ts files, and then directed Karma to watch the resultant .js files. This is perhaps easier to comprehend by someone who is easing into tests, but it might not be the most efficient way to go about it. Karma also supports TypeScript Plugins, which allows you to pre-process the files into TypeScript before handing them off to the Webpack preprocessor. Karma supports the chaining of pre-process steps, which will be useful if you want to compile the TypeScript on the fly as part of pre-processing. In this video, we created a unit test suite. Awesome!